Hey y'all, welcome back. This is going to be lecture number 19, covering chapter 5.5 over linear inequalities. We're going to jump right in. So we're going to start with a couple of definitions. An equality in the form ax plus by is less than c, where a and b are not both zeros, called a linear inequality in two variables. And the symbols could be either less than, greater than, less than or equal to, or greater than or equal to. And then a solution to this inequality is an ordered pair that satisfies the inequality, and the set of all such ordered pairs is called the solution set. And we're going to do an example first. We're going to sketch the graph of 3x minus 2y is less than 6. So the first thing we want to do is sketch the actual line. To do that, I'm going to put it into slope-intercept form. So we have 3x minus 2y equals 6. Which means negative 2y equals negative 3x plus 6. So we get y equals 3 halves x minus 3. All right, so first I'm going to draw this line. I've got my y-intercept at negative 3, and my slope is 3 halves. The next thing that we want to look at before we draw the line is we want to see if it's less than or if it's less than or equal to. So when you have either less than or greater than, you're going to draw a dotted line. And if you have less than or equal to or greater than or equal to, you're going to draw a solid line. So since we have strictly less than up here in our original inequality, we're going to draw a dotted line instead of a solid line. So it'll be like this. Okay. And then the last step is to essentially find a test point to figure out on which side of this line does this inequality hold true. So I'm going to choose the point 0, 0. So that means we'll have 3 times 0 minus 2 times 0 is less than 6. Which just means 0 minus 0 is less than 6, 0 is less than 6, which is true. So what that means is we are going to shade in this side of our graph. So this is all the space of the plane where 3x minus 2y is less than 6. If you plugged in a point from the other side of the graph, you should get something larger than 6, which is why we don't shade that in. So just to do an example, I'm going to do like 10, 0. It's way out here on this x-axis, right? So that means we'll have 3 times 10 minus 2 times 0. That's going to be 30, which is not less than 6, right? So that would be false. So that's why we only shade in this side, because that's what makes our inequality true. Okay, so let's keep going. So we're just going to do some more practice similar to our first example. Our first one's going to be 4y is less than or equal to 3x. So again, I'm going to graph the line first. So the line 4y equals 3x. That means y equals 3/4 x. So my intercept is going to be the origin. And then my slope is 3/4. And then since I have less than or equal to, I'm going to have a solid line instead of a dotted. So I have this. The final step is to pick a point and figure out if it is satisfying our inequality. So we've got 4y less than or equal to 3x. So I'm going to pick the point here, which is 0, 2. So that means we'll have 4 times 2 is less than or equal to 3 times 0, which means 8 is less than or equal to 0. So this is false. So I'm going to pick a different point now. So let's pick one below the line. Let's try 0, 2. So that means I'll have 4 times -2 is less than or equal to 3 times 0. Which means I have -8 is less than or equal to 0, which is true. So I want to shade everything below this line. So my solution set is down here. And then for number 2, again, we're going to graph the line. So I get 3y equals 5, which is y equals 5/3. That's kind of close to 2. And then it's like here-ish. And then I'm strictly less than, so that means I'm going to do a dotted line. And remember, whenever we have an equation that's y equals, we have a horizontal line. When it's x equals, it's vertical. So we've got this dotted horizontal line at 5/3. We want to figure out where is y less than 5/3 and where is y, where 3y is bigger than 5 and where it's less than 5. So I'm going to plug in the point 0, 0. So this is going to be when y equals 0. I have 3 times 0 is bigger than 5. So 0 bigger than 5 is false. And you can even take the next step from here to say, I know it has to then be above this line. Or you could plug in another point. So you could plug in like 10, say, and you'd have 3 times 10 is bigger than 5, which means 30 is bigger than 5, which is true. So you can tell that this is our correct solution set. All right, let's keep moving on. So now I want to graph a system of linear inequalities. This is going to be slightly more challenging, but we can still do it. So the first thing we're going to do is deal with, I'm going to do line A first. So we'll have, this is just y equals a half x plus 2. It's already in that slope-intercept form for us. And then it's less than or equal to, which means I'm going to make a solid line. All right. So my y-intercept is 2, and then slope of a half. So there's my line. Now I'll do the other one. We'll call the other one line B. So that one is 3x minus y equals 3. So that's going to be y equals 3x minus 3. So my intercept is -3, and then my slope is 3. And then since it is strictly less than, we're going to make a dotted line. So now we've grabbed line A and line B, and we need to figure out where we're going to have spots that satisfy both of our inequalities. So what we're going to have to do is we're going to have to pick a point in each of their little sections. So here's our first section. We can pick, let's see, 1, 2, 3, 4. So this is 0, 4. Then we can pick this point here in our second section, which is 1, 2, 3, 4, up 1, 2, 3, 4, 5. So this is 4, 5. And then we'll pick one over here. We can pick this coordinate here, which is 3, 0. And then lastly, we need one in our fourth section, which is going to be, we'll pick -1, 0, just trying to pick small numbers, make our lives easier. And then I'll label them. So this is going to be 1, 2, 3, 4. I labeled them according to kind of quadrant. But okay, so we'll check point 1 first. So we just plug in 0, 4 into both of our inequalities. So for inequality A, we'll have 4 is less than or equal to 1/2 times 0 plus 2, which means 4 is less than or equal to, this is just 0, so we get 2. So false. Okay, so we know that our solution does not lie in quadrant 1. Okay, let's do quadrant 2. So we get, again, starting with inequality A, we get 5 is less than or equal to 1/2 times 4 plus 2, which means 5 is less than or equal to 2 plus 2, which means 5 is less than or equal to 4. Again, this is false. So our solution does not lie in quadrant 2. Okay, next we'll check number 3. So equation A, we have 0 is less than or equal to 1/2 times 3 plus 2, which means that 0 is less than or equal to 3/2 plus 2. This is going to be true, right? So then we'll check B, and we'll get, let's see, that's going to be 3 times 3 minus 0 is less than 3. So 9 is less than 3, so false. So our solution does not exist in the third one either. And last but not least, we'll check the fourth one and hope our solution exists there. So starting with equation A, we'll have 0 is less than or equal to 1/2 times -1 plus 2. So that's 0 is less than or equal to -1/2 plus 2. And -1/2 plus 2 is positive 3/2, so this is true. Okay, and then we'll check equation B. So we'll get 3 times -1 minus 0 is less than 3. So that's -3 is less than 3, which is true. Yay, we found our solution. So our solution is going to be in what I called section number 4, which is this one. So we shade this area. So that is our solution to our system of inequalities. They both have to be true for it to be true for the system, similarly to when we were solving just systems of linear equations. All right, let's keep moving. So now I want to graph a nonlinear inequality. So a nonlinear inequality is going to be anything that is like a parabola or a polynomial. In this case, it's going to be a circle. So what I'm going to do first is just write the equation. So we have x minus 2 quantity squared plus y squared equals 9. The equation of a circle is going to be x minus h squared plus y minus k squared equals r squared, where h comma k is the center of the circle and r squared is the radius squared. So that means the center of my circle is going to be at 2, 0, and the radius is going to be 3 because the square root of 9 is 3. Since r squared equals 9, the radius is 3, right? Radius is always positive because it's the distance away from the center. So 2, 0 is right here, and then my radius is 3, so I'm just going to kind of pick some points that are 3 spaces away from my center on every direction. The next thing we need to look at is whether or not we're going to have a solid or a dashed line. So since it is strictly greater than, we're going to have a dashed line defining our circle. So that means we'll have something like this as we connect these dots. Okay, so there's my circle. The last thing we just need to check for is where in our plane satisfies this equation. So I'm going to check a point inside the circle first. So the origin is inside the circle, 0, 0. So that's right here. So I'm going to check 0, 0 first. So that means we'll have 0 minus 2 squared plus 0 squared is bigger than 9. Negative 2 squared is 4. So is 4 bigger than 9? No. So this is false. So by default, we know that the area I need to shade is going to be outside my circle. So it's the entire plane, except not inside the circle. So all of this area. All right, let's keep moving on. So here's another inequality with a nonlinear function. So what we want to do is, again, first graph it. So I have a typo. This should say minus y. I will fix it on the lecture notes uploaded on tracks, but it should be minus y is bigger than 0, like this. So what we're going to do is first graph this function. So we'll have x minus 1 squared is equal to y. So then what we'll do is we need to find the vertex of our parabola. So it's going to be 1, 0. And then we know that it opens upward, right? So our vertex is going to be here at 1, 0. And then from here, you'll plot some points. And then the last thing that you need to do is figure out whether it's a solid or a dotted line. It is a dotted line because it's strict, right? Strictly greater than. So that means we'll have something kind of like this. Okay, dotted parabola. And then kind of similar to the circle problem, we just need to figure out the area in which we need to shade. So I'm going to pick the origin. I love to pick the origin. It's the easiest spot to pick because it's just 0, 0. So that means we'll have 0 minus 1 squared minus 0 is bigger than 0. So we'll have 1 is bigger than 0, which is true. So that means we are going to shade our outside area. Means whatever is inside is going to be false. We can check it if y'all want to see. So like, let's pick the point here, 2, 0, which is inside my parabola. So if we picked, I'm sorry, 0, 2, we would have the 0 minus 1 quantity squared minus 2 is bigger than 0, which is 1 minus 2 is bigger than 0, which would be negative 1 is bigger than 0, which is false. So you can see that the points inside the circle make the inequality false, and the points outside the circle, I'm sorry, the parabola, make the inequality true. So we want to shade only outside the parabola, only what makes our inequality true. All right, let's keep moving on. So now we have a system of nonlinear equations, and we want to graph all 3 of them and find the solution that makes all 3 of these true at the same time. Wild, right? So what we're going to do first is I'll label them. So we'll call the first one equation A. And so we'll have y equals negative x squared plus 4. So our vertex is going to be 0, 4, and it's going to open downward because of the negative in front of the x squared. And then I know I need a solid line because it's less than or equal to an equation, or I'm sorry, an inequality A. So 0, 4, 1, 2, 3, 4, up here, opening downward. So it's going to be kind of, all right, like this. Okay, inequality B. We're going to have x minus y equals negative 2, which means that x plus 2 equals y. So my slope is 1. My intercept is positive 2, which is here. And then this is nice because it's just up 1 over 1 to graph this line. So we'll have this line here. Oh, sorry, it was solid because it's also greater than or equal to. All right, and then the very last step we need to do is going to be inequality C. So I have another typo. So this should say y is bigger than negative 5. I've corrected it in the lecture notes that are uploaded up on tracks, but y is bigger than negative 5 is our actual inequality. So it means we're going to set it y equals negative 5, and we're going to have a dotted line since it's strictly greater than. So that's 1, 2, 3, 4, 5. So we're right here. and we are dotted all the way across y equals -5. All right, now we know we want to be larger than -5. So all the numbers on the y-axis that are larger than -5 for our inequality C are going to be up here. So we know that we are only interested in this region, right? So we don't even need to check any of the numbers that are down here. This is the spot where y is larger than -5. All right, so now we just need to start choosing some points to see where our equation is true. We're going to start with my personal favorite point, which is 0, 0. We're going to check it with equation A and with equation B. So with equation A, that means we'll have 0 less than or equal to 0 squared plus 4, which is 0 is less than or equal to 4, which is true. So far, so good. So let's check with equation B. So we'll have 0 minus 0 is greater than or equal to -2. So 0 is bigger than -2. That is true. So it looks like we've already found our region. Now note, if I pick another point above this green line, so I'm here in this zone right here, so I can't cross any of my lines. All right. So if I pick some point above that green line, like 1, 2, 3, commas, or 0, 3, for example. So let's just talk about the point 0, 3. So if I plug that into equation B, I would get 0 minus 3 is bigger than or equal to -2, which is -3 bigger than or equal to -2, which is false. So I can't have anything above the green line or outside my purple parabola or below my blue dotted line because I have to be strictly bigger than -5. So to meet all three of these inequalities, I'm this red shaded section right here in the middle. And that's it. So hopefully that wasn't too bad. I thank y'all again for watching these lectures, and I hope you have a fantastic rest of your day.